This new solar tracker design suspends the panel from above, which saves space, boosts bifacial output, and allows mounting on walls, balconies, or pylons. I've been using a fake wooden panel to work out the kinks, but honestly the power generation isn't great with that, so it's time to add a real solar panel. The problem is that standard mounting options are made for trackers where the panel only rotates a little bit. This panel's going to move. A lot. We need a strong frame here. During this video, I'll be going over the framing of a panel for this suspended design. Here I'll show sizing the frame to fit just right, making the mounting brackets, adding corner braces, then I'll briefly spiral into self-loathing and despair, and do a final fit check. Keep an eye on the background. There are hints of upcoming improvements, including the new axis design. I'll point out those Easter eggs at the end.
Nice panel.
Thanks.
What? Why are you laughing?
Alright, I'm excited to get started. I don't even bleed in this one, hopefully. Getting the frame snug is tricky. Too loose and it slides, too tight and you crack the panel, which is bad. Foam tape is a possibility, but it needs to handle weather, UV, and compress a lot. Neoprene weather stripping fits the bill for all these requirements, but how do I account for this in my frame dimensions? Measuring one piece is hard to do accurately, so I'll stack 10. I'll measure the percentage that this stack compresses with a moderate amount of pressure, multiply that times a single layer height, double it for both sides, and add that to the frame's dimensions. Alright, got my framing, now let's put this together. First, I need to drill some holes. I'll use a custom 3D printed jig because I don't trust myself to eyeball it correctly. And I'll use cutting oil because smoke seems bad and I don't like buying new drill bits. Here I use a little container of Isopropanol to clean out the cutting oil and aluminum shards. Now to tap the holes on the end to put the screw threads in them. If you're a psychopath and want to see the build in even more detail, or just like the clinking and clanking as background noise, I posted a 2-hour video of the full assembly process in the Rough Cuts playlist. Now for assembly. One issue I was shocked to learn here is that stainless steel actually corrodes aluminum. To prevent corrosion and to be kind to future me, I'm using dielectric grease to keep moisture and air out of the gap. Dielectric is the key word here. It means the grease won't conduct electricity. The wrong grease could actually speed up the corrosion you're trying to stop. In a final version, I'd add Loctite to keep the screws from ever backing out, but since I'll be tinkering with this constantly, I'll skip that for now. Let's add the foam tape. Can you stand that part up? Okay, good. Just hold that right there. I'll put it down on there. There you go. That's good. Okay, cool. Now I'm going to put this piece on. It looks like it's a decent size already, which makes me happy. So that's going to compress a little bit, but at least it'll be snug. Doing a good job. Thanks for your help.
Is there anything we don't need?
Is there anything we don't need? Oh, parts you can use for your stuff?
This is taking a long time.
I'm sorry. Lay it back real easy. Okay.
I can leave now?
Yeah, I might need you in another second. Or I'll get another kid.
I want to raise my allowance.
I'll put that through those slots. Good. Perfect. Now, I need to tighten these.
This is Tslot framing, right?
This is Tslot framing, yes.
Got it.
I don't think that one will fit. Thanks for trying. Unfortunately, there's a small gap here, so I'll have to triple layer the foam tape. That's way bigger than the rounding error I expected when ordering the cuts, so that mistake's on me. Adding another layer of foam tape took care of that gap. A snug frame isn't enough to hold the panel in place, so we need mounting brackets. I borrowed some I used on my fake panel. Maybe those are close to what I need. Nope, off by a bit. I made some tweaks to the design by making it shorter here. I also added some more material at this corner here to make it a little stronger. Finally, I had to account for the rim around the edge, so I added a curved gap. Here, if you print the whole part every time, it'll take hours for each iteration. Instead, just print the minimal amount to make sure everything fits. This dramatically decreases the iteration time from hours to minutes. I do this in PLA filament because that's biodegradable, on geological timescales at least. No need to use the heftier PETG plastic until we're done troubleshooting. First fit test looks great. Pretty psyched about that. But will it still fit once it's screwed in? Let's find out. Here I need to add the padding to make sure the brackets fit with that on there. This one with the gap for the rim is off by a bit, so I'll need to tweak it, but I think I'm close, so I'll make the change and go ahead and print it in PETG. Now to test these out. These fit really snug. Let's print the full set and get them mounted. There we go, brackets in place. That should keep the panel in place, but it won't prevent twisting. Any movement could cause microfractures in the panel and end the world as we know it. To prevent that, you're welcome, I'll add some corner braces. Maybe this is overkill, but I'd rather start off with too much and back off later if I can. Forgive the hodgepodge of different screws and T-nuts I used here. I way underestimated the number I needed and ended up using whatever I could find to finish. Next, I'll add an extension arm to hold the magnetic rotary encoder. That's the part that tells the controller the panel's angle of rotation. Before showing the final fit, honestly, I'm feeling pretty frustrated. I tried to be meticulous in making my measurements, but still somehow made everything too long. That's better than too short, because then I'd have to rebuy everything, but still. And the corner braces, I felt like those could have been maybe a thin strip instead of these big bulky things. Sometimes though, when I'm feeling frustrated and wondering if any of this is gonna work, I'll listen and I'll hear this sawing or hammering coming from around the corner. Maybe you could hear it on the video. That's the kids building stuff. And they don't do that if I'm not building things. And I can't pay them to build stuff if I'm not doing things. So maybe the thing that's really the most important here is if they see us going for it, even if we fail, they'll go for it too. Anyway, if you think this project's cool and want to help out in a tangible way, right now, every like matters. So thanks for that. I really appreciate it. Now for the final check. Here's the finished version next to the unmounted frame. What do you think, Internet? Will these braces hold? Is twisting still going to affect the panel? Let me know in the comments. Maybe you noticed these spoilers for future videos in the background. The decision's been made on the new axis design, and the parts for that are here. You can probably figure out which design I'll be doing from that. Also, I'm revamping the worm gear so it's no longer cantilevered. The draft for that is right here. If you want to see what happens next, click this video right here. If it's not ready yet, then be sure to hit subscribe and click the notification bell so you don't miss it when it comes out. And if you want to see how I got to this point, you can click this video over here. All right, thanks for watching. I'll see you in the next one.